Hello there, welcome to RPI Data Science. So from today on, I would like to do something very different, which I haven't done in the past. I haven't done any videos. Also, I have really worked very much in it for the last 2 years. I haven't done any video on it, but it might be a good idea to share my what I have done myself in text mining, text classification. We do some text modeling. Text really very important data types. If you look at if you're dealing with sentiment analysis, or if you are doing tweet analysis, or maybe if you are working in a systematic review or something, you may be interested in doing some text analysis, or looking deeper into what the content of the text is actually. And depending on the content of the text, you can actually do some topic modeling, or maybe you can automate text classification. Let's say if you are dealing with sentiments, for example, you may have like reviews written to a certain product, which might be negative or positive reviews, and based on the contents of the review, you may be you can classify the comments whether they are negative or positive reviews and the like. This is language models are really game-changing things. I mean, all the things that you are writing on your Twitter or on your Facebook platform and so many other medias, you always leave text data, and this text data is actually very important, and it's really also computationally intensive. So it might be it's interesting to look at it. So I would like to show you something. So first thing first, let me show you something. So what are we gonna do today? Let me just start my presentation. So we do text mining and supervised text classification. The first thing we will try to do is reading biomedical literature, text data, mainly about COVID literature, and we'll do some, based on that literature, we'll do some biometric analysis, bibliometric analysis, we'll do text analysis, and at the end we'll do some supervised text classification techniques. So we will implement several classification techniques, from the basics, logistic regression, up to things like regularized logistic regression, such as lasso, ridge, or elastic net, or the likes of support vector machines, XGBoost, extreme gradient boosting. These are really very popular models in text analysis. I mean, secondary to the state of the art deep learning models. So it might be a good idea to have a good knowledge about these techniques. I personally have worked a lot on text analysis, mainly on biomedical literature, because I implement these text analysis and text classification methods to facilitate a systematic review process. So I have plenty of experience in this topic. At least for the last 2 years, I have been very much deep into this field, and I have learned a lot, and I would like to show something. I would like to share what I have. So there are plenty of packages where you can do text analysis, text mining mainly. So the main package that I really like are Quantida. Quantida it's really, for me, it's one of the best things that if I'm dealing with text data, if I'm working in R, then Quantida is one of the best packages I can suggest to work on. But there are also other packages like TM or Tidy Text, Text to Vec. These are also good, nice package to look into. But in this series of videos, I will mainly show some of the contents of some of the implementation of Tidy Text, But mainly for the tidy text is mainly to analyze my text mining, to identify the most frequent words, and to develop some word cloud, or some bar charts or things like that based on the text data you have. But for the machine learning, I would very much prefer to use Quantida, because Quantida is more user friendly. I really like the way Quantida is implemented. It has so many powerful functions. It has also actually some inbuilt machine learning models, such as I think it used to be naive Bayes and support vector machines, mainly linear SVM from Quantida text models, but they have recently added, with the recent upgrades, they have also added regularized logistic regression models, such as Lasso, Wedge, or ElasticNet. So I very much like Quantida, and the good thing with Quantida is actually, I mean, they are really very active. When you write a question in Stack Overflow or something, the people are very helpful in solving your questions. So but there is also another package which is also very popular, TM package. You may also look at it. I tried to to have some I tried many different packages, and then in the end I decided to mainly work on Quantida, and sometimes I use tidy text package. So for today, what I want to show you is mainly on reading text data, mainly biomedical literature text data. So that's what we need. We will read biomedical literature in a sense. When the paper is published, you have the title, the author, the year the paper is published, and the name of the journal, the abstracts, keywords, and those things, where you have. So we'll have a bibtext file, to read that bibtext file. There is one popular package called Bibliometrics. So we will use Bibliometrics package. That's to read the bibliometric reference data, and also to do some bibliometric analysis. It's really quite a useful package. We can also do dplyr. It's just for some data management, and ggplot2. You may also need that, because in fact some of the package they have you need to upload ggplot2 so that you can use the other package. Then also we can, as I said, we will also need to use tidy text. It's also a very, very handy package. They have really nice book also. You may also look at it. And another package that you can look at is bib2df. That's also a package to read bibliometric references, but I will mainly use the this one and this and the other ones, but I'm just loading it so that you can see it and you can have a look. The other one is word cloud. Word cloud is a ggplot of words. So you create a cloud of words, and that's it's a package. So these are the packages that I need, so I can simply load them. So once I load them, I need the data now. So I have my bibliometrics package loaded. This is a reader, so it reads my reference data, bibliometrics bibliometric reference data, and then once I read that, I can also do some bibliometric analysis, like author keyword collaboration, or maybe author co-occurrence and keyword co-occurrence, and like. It's just to have a brief overview of how your data looks like. It might be interesting to do some bibliometric analysis. So for that, what I want is I will show you I will drop the link at the end of the YouTube tutorial. So this is my from my GitHub page. These are the references. It's a large bibliometric bibtext file. So you have the abstract, this is the ID, and you have the journal and the like, and all of this, they are already in the file. So what I need is I can just click the row, and I can simply grab this URL, and then once I do that, what I do is I can simply save the URL, and then I can put it in a quotation mark, and then run it. So I have the URL of that. Otherwise, you can also download it and you can read it with your Bibliometrics reader. So then next, because this data is about COVID, let me call this COVID-19 bibliometric, actually bib analysis, and let me call it that way. And then one of the most you can just question mark. You can also say help bibliometrics. This is here, and then you can have detailed documentation of the package, or or something, and all the functions that you may want, you may be interested in looking at. I will not go into the details. There are many powerful functions within this package, but I will just use this convert to DF. That's this is my reader, so that's convert to DF. As you read CSV file, for example, using read CSV. So for this, you use convert to DF, and they are convert to DF is mainly so R is giving you the file type, the DB source. The DB source could be ISI or Web of Science, Scopus. It's just where you downloaded your bibliometric references. I downloaded from Web of Science, from ISI, so I can simply actually ISI and Web of Science, it should not matter. It should not be. So the default is ISI. You can also keep it blank, and still you will be able to read it. So the first thing is the source. That's URL. That's the type of the data we have. So I can simply add URL. You can ignore it. This is to a DB source. You can ignore it, or you can simply define ISI. That's the default. Or you can, depending on your source, you can also mention PubMed or Scopus or something. And then you define at the end the format. The format could be, I believe they accept many other, but we can also add. As always, you can simply write convert to DF and see the arguments within the package. Let me scroll this a bit up, and you can see convert to DF, DB, and the format could be plain text or bibtext. So I will use bibtext. Format could be plain text, indnode, bibtext. This is my format because the file format at the end of my link is bib. So because it's bib, so my file type is bibtext. So I can simply write this here, and I can simply run this. So now it will take a little bit of time to read my reference. Now it's already done. So I have already 601 observations and 23 variables. We can have a small overview of how our data looks like. So the first one is the row identifier, and the next one is the author names, and then DE is a keyword, then abstract, it's writing it all in caps. We can manipulate that, but and also the DY, SN, SO, yeah, many other things. But we will mainly be interested in the title and in the abstract, in our text analysis. That's what we will be mainly interested in. So these are all about COVID and SARS. So it's mainly about COVID and SARS. So we will do text analysis using this data. So at the end, what we do is we will do a text analysis using this data, and then we will be able to classify whether this data is actually whether a certain a certain document or a certain observation is either COVID or SARS. We will predict that. That's what we will be doing in our in my upcoming videos. So for today, this is what we need. So we just we were able to read our references, our biomedical references, and then next we will do some bibliometric analysis. Once you read the your data, you can have a look, you can have an overview of your data, and then at the then you see how your your co-occurrences and those kind of things. But we can also do maybe one quick analysis. That's bibliometric analysis. So let's just do that, and we will wrap up and finish for today. Maybe how long am I? Let me check. It's already okay, 16 minutes. Probably it's enough to stop it and then refresh. Yeah, okay, let's just continue. So you can have a look from the bibliometric package. They have a nice tutorial. So what you can do is you can label it, let's say, results, and what you do is biblio analysis. That's one of the functions. So what you do is so it gives you some, and then the data, that's what our data is, and then you can use separator. That's you can put it in a comma, because that's the separator of our within our data. That's a comma separated, and this will create an object. And then what we can is we can give it an options. That's pretty really described in the package tutorial. You can also have a look, and then you can define, let's say, 100. It's just to see the width of the number of documents that we would like to look at. So let me run this, and then we'll see some results. So finally we do a summary. Let me just copy the code from the package tutorial. So let me call this S, and then we see the 10 most prominent authors in this in this paper, because we have 601 observations and 23 variables. If you remember, there are author names. So this package will go through all the author names. It does some text analysis, and then it will rank the authors for us. So let me run this, and then we will have no, okay, sorry, I made a mistake here. Let me escape this, and then let me close this bracket, and you see the most prominent authors in the field. So these are the main journals that published a lot of papers in the topic. These are relevant sources, and these are the DOIs, the most influential. But we can also go up, scroll up, and see who are actually the influential. These are citations. I don't think we have citation detail, because I didn't download the citation data from when I was downloading the data from Bioscience. But you can see we have about author supplied keywords 269, and we have about 594 authors. So there is definitely like one author publishing multiple papers And we have author appearances, 601, author of single author documents, we have about 594. This doesn't seem to be real, but it seems there is some kind of error. But yeah, and year, it's most of them are in 2020, but there are a few articles in 2021. And these are the annual percentage growth rate. It's 99.6. No, it's growing. It's not, because it's, you know, from 599 to 2, so it's not growing. And we have the main authors. These are there is one which doesn't have any author name, but these are the most like I mean, it's not really the most, but they are at least the top writing author in the list of these 600. So this guy has 3 papers. Next one has about 2, and it goes on and on. Yeah, so this is just a very preliminary bibliometric analysis. We'll do further in further analysis, further bibliometric analysis, like a cluster dendrogram and the like. But for today, that's enough, and we can do further in the next series of videos. Thank you very much, and have a great time. And I would be happy, I would be very happy if you like the video and subscribe to the channel, so that that will be good motivating for me. Thanks.